This is part 2 of composition of functions. We'll look at finding the composition of functions from a table and graph and investigate the domain of the composition of functions. So to get started, how do we use a table to evaluate a composite function? Well, for example, below, we have f composed with g of 3 and g composed with f of 3. So those are two different things. So let's write those down using the other notation. So for the first one, f composed with g of x is the same as f of g of x. So in this case, we're going to find f of g of 3. So using the table, we first want to find the inside function g of 3 and make that replacement. So g, there's our x value, g of 3 is 2, and then f of 2 is 8. So we're going to get an 8 there. For the second example, we have g of f of 3. So we first find f of 3. So our x value is 3. So we have g of 3, and g of 3 is, again, 2. So that's how we use a table to find a composition. We can also do that using a graph. So if we're going to look at the graph to evaluate a function, if we have the two graphs, in this case we have g of x and f of x, and I want to find f of g of 1. So what I'm saying here, I start from the inside. I want to say, what is the function value g of 1? So at 1, right here, I'm going to follow this up, and I'm going to get 3. So now I have f of 3. And then I'm going to look at my graph of f of x, and at 3, I'm going to follow it up, and our y value is 4. Our function value is 4. So that's how you use a graph to evaluate a composition. When we find the domain of a composite function, we first have to find the domain of the inside function, and then we find the domain of the outside function, and then we exclude the inputs from g of x where the outputs are not in the domain of f. And the best thing we can do here is just do a couple of examples to give you an idea. So let's first, for this function f of x, we know what the domain is. X minus 2 cannot equal 0, so x cannot equal 2. And for g of x, this function here, we know that the domain comes from x plus 4 being greater than or equal to 0, or x being greater than or equal to negative 4. Okay. All right. So we want to find the domain of f of g of x. So I can plug in any value greater than or equal to negative 4 into g. The question is there anything that I would put in there? So in other words, is there anything where x plus 4, the square root, would be equal to 2? Because I can't have 2 in my outer function. So I'm going to square both sides. X plus 4 equals 4. and subtract 4 and I get x equals 0. So our domain for this composition, we know it first has to be greater than 4, greater than negative 4, or equal, but we can't have 0. So let's write that in interval notation. Negative 4 up to 0, union 0 to infinity. Let's take a look at another example. For this example, the domain of f is that x cannot be 1, because plugging in a 1 would make that denominator 0. This should be a g of x here, I think. And the domain of g would be 3x minus 2 cannot be 0. So x cannot be 2/3. All right, so the question is the value of g of x 4 over 3x minus 2 ever equal to 1? And if it is, we need to exclude that x value. So I'm going to cross multiply. 3x minus 2 equals 4. 3x equals 6, so x equals 2. So in general, we would say that the domain of g would be anything as long as it's not 2/3. But we also have to exclude anything that makes the g of x equal to 1. So we're going to say x cannot be 2/3 or 2. So let me put that on our number line here. Here's 2. We can't have that. And 2/3 would be about here. 2/3. But we could have anything else. So we're going to say negative infinity up to 2/3, union 2/3 to 2, union 2 to infinity. That one was a little tricky. All right, this information here is going to be for our next video, so we're not going to worry about this here. And that concludes this video on composition of functions, part 2.